So let's start with our functions of several variables. Let me show you some examples of what these things are. So what we could do is model the temperature at any point on the surface of the Earth by giving the temperature as a function of the latitude and longitude. So if we let x be the latitude and y the longitude, we might say something like this. Temperature is a function of x and y. So we have a function of two variables. Here's one that you're probably familiar with, the volume of a cylinder. The formula for it is in terms of radius and height. So we could write the V as a function of R and H. How about things that are functions of three variables? If you've been in chemistry class, you've probably seen the ideal gas law. The pressure of a gas can be written in terms of the moles, the temperature, and the volume. Now, if we use these letters, these are the traditional letters used to represent moles, temperature, and volume. N for number of moles, we can write the P as a function of N, T, and V. So we have a function of three variables. In physics, the law of gravity says that the force of attraction between two bodies is related to the mass of each one and the distance between them. If we use a lowercase m for the mass of one and a capital M for the mass of the other, and d for the distance between them, then F is a function of lowercase m, capital M, and d. So we have a function of three variables. How about something that's a function of four variables? For example, the heat flow through a surface is calculated by knowing the surface area, thickness, and the temperature on each side. So we might do something like this: area A, thickness D, T sub 1 and T sub 2, the temperatures on each side. So we would write a function similar to this. Now, it would obviously be somebody's job to come up with what that function is. And actually, this is something I did in my third semester physics class. So Q, representing heat quantity, that's a traditional letter for heat, quantity, is a function of four variables. Now our final example, here's a function of four variables. We got P, the sum of money invested, the interest rate, the method of compounding, like monthly, quarterly, and so on, and the time. So the future value is a function of those four quantities. And there's a formula for such a thing. We want to focus in the beginning, however, on functions of two variables. And it's traditional that we use the letter Z to represent the third variable. So we say Z is a function of X and Y. And here's the idea. We're taking a planar region, like I've got graphed here, and we're mapping a point in the planar region, a point in R2, which means 2 dimensions. A point in 2 dimensions is mapped onto a a point in one dimension. So that's the idea of z being a function of x and y. Notice the normal procedure is when we give points in this system, we give them as ordered triples with the x, then the y, then the z in that order. Nearly all graphing utilities that help us visualize functions of two variables use z as the third variable. So typically we have the x, y, and z coordinate system. Now it's assumed that z is a function of x and y. Many graphing utilities can only handle functions of x and y. Now of course you'll see in our assignments and all, Maple doesn't necessarily need us to have functions of x and y. Now here's a function, e to the 1 minus x squared minus y squared. That is a function of x and y. We can type this in Maple just using the plot 3D command. We'll do some of that on our homework. Now, in the past, we've used this free plotting program called WinPlot. I've put a link down here on the bottom of the screen to a website that you can download that if you so desire. It's a free program. Unfortunately, the author, the guy that wrote the program, died in 2012, but there still are people out there that have his program available for free. There's another program called dpgraph that we have used before. There's a link down at the bottom of your page to a website, the dpgraph website. Now if you use this link to get to the dpgraph website, you'll see a list of institutions that have helped establish the dpgraph program. Pick Texarkana College off the list, and you can download a free version of the dpgraph that draws three-dimensional graphs. Now the TI-89 actually has a 3D graphing setup, so you could set your mode to be 3D and draw 3D graphs. I'll give you a little word of caution. It takes quite some time for the TI-89 to draw a graph, and if you go to move it and look at it from different angles, it takes a long time to do it. The TI Inspire is a newer version of the TI-89. Works a little bit different, but as you can see, the graphs are colored. We also have a box with the coordinates marked on it, which makes it kind of nice for knowing what is located where. And if you just go to the browser and do a search for 3D graphing programs or 3D graphing utilities or 3D graphing calculators, or I guess just 3D graphing, you can see tons of them out there. You just have to kind of experiment, find one that works and that you can understand. I found that this one is a pretty nice and easy to use and understand one. We want to talk about finding the domain of functions of two variables. Remember, back in algebra, when we had a function like this, the square root of x minus 2, we just needed to know that the x minus 2 inside the radical had to be greater than or equal to 0. We solve that and we get x greater than or equal to 2. Well, in one dimension, we have all the numbers greater than or equal to 2, which would look like this. So here's a graph of the domain of that function. We actually have a way of saying that graph, like we have here. And for functions of two variables, we want to do something similar. We want to look, for example, at the bottom of this fraction, and remember that x minus 1 cannot be 0. You can't be dividing by 0. That means x cannot be a 1. Very similarly, in the top, the x plus y plus 1 has to be greater than or equal to 0. So if we modify x plus y plus 1 greater than or equal to 0, we get y greater than or equal to negative x minus 1. Well, the y equals negative x minus 1 is a straight line. Here's the graph of that. So the straight line, y equals negative x minus 1, and everything above it, except for what's along the red line, is the domain of this function. Here's one more example finding the domain of this function. Again, very similar to the last one, we need the stuff under the radical to be greater than or equal to 0. And changing that up a little bit, we get x squared plus y squared less than or equal to 9. Well, I recognize that x squared plus y squared equals 9 is a circle, radius 3. X squared plus y squared less than or equal to 9 would be everything inside of that circle. So the domain of this function is everything on the red disk along with everything on the blue circle because it's less than or equals. Now, as I showed you earlier, the best way of visualizing functions of two variables is to actually find a graphing utility that'll handle it and draw it out so that you can see what's going on. Sometimes, however, that's not feasible. So I wanted to show you one way of representing functions of two variables, and that's to use what's called level curves or contours. Now we will actually do this together in one of the Maple assignments, and I'll show you that in Maple. However, let me show you. We're going to take the function square root of x squared minus y, and without drawing it, which we could do easily in Maple, we're simply going to pick out some values of z, plug them in, and draw the graph of that. Now, you could do that with a TI-84 with a little bit of manipulation. So here's the graph when z is a 0. Here's the graph when z is a 1. Here's the graph when z is a 2. Here's the graph when z is a 3. So we've drawn 4 graphs for different values of z. Now, these are called level curves because if we're looking at this in 3 dimensions, each of these lines would represent the same vertical level, the same z value. And so this is our representation of the function square root of x squared minus y if we don't have any other way of drawing it or visualizing it. We kind of represent it with level curves. Now we can't even begin to draw the graph of this function, even in Maple, as powerful as it is. Yet notice our function is a function of 3 variables. We've got x, y, and z, which means our 4th variable, whatever that is, how about w, is a function of x, y, and z. So that means we've got what? We've got our variables x, y, z, and w. If I'm not mistaken, that's 1, 2, 3, 4. I don't think you're going to find any graphing utility that will graph in 4 dimensions. So we can do a little technique similar to what we did for functions of 2 variables. We can draw what's called level surfaces. Now we will do this in Maple. I'm not even going to attempt a hand drawing for level surfaces.